Hi, Newton from Pynest is back with you. Today I'm going to talk a little bit about microservices. Microservices architecture is one of the most popular architectural patterns today. It allows you to divide a single large monolithic application into multiple small applications that perform specific tasks. Each team can focus on developing only their own microservice and, in some way, result autonomously from other teams. Individual services are deployed without the involvement of other teams. In addition, each of them can be deployed completely autonomously. Metrics, Amazon, and Uber are examples of companies that are successful using microservices architecture. Netflix operates more than 700 microservices for video streaming and content recommendations, allowing you to quickly roll out new features and ensure a stable experience. Amazon uses more than 1,000 microservices to manage orders, inventory, and payments, while Uber uses microservices to calculate fares, road drivers, and process payments. What are microservices in short? Microservices architecture is a popular approach in which a large application is divided into smaller services, each of which performs a different task. Imagine that you own a large chain of stores, a lot of orders, various discount systems, delivery, and use. All this requires organization and coordination. Each of these tasks is a separate structure that must work effectively, both independently and in conjunction with others. And so you might be wondering, what do microservices have to do with it? Microservices are like separate departments in your company, each with its own specific task. For example, a service for managing promotions and discounts, a service that tracks the status of orders, a service for conducting payment transactions. What does that mean for us? Shared responsibility. The principle of single responsibility cannot be underestimated. Each microservice is focused on its specific task. Not only it's simply controlled, because each service has a smaller code base, but it also makes the systems more manageable. If one of the microservices goes from location, for example, fails, the others will continue to work and the application will remain available. The user may not be able to use a particular feature temporarily, but the other will work properly. This property is called fault tolerance, and it's critical for scalable systems. What if one microservice cannot withstand the load? No problem. Write an additional port if you are on Kubernetes or another server. Install a load balancer and distribute the traffic. How many servers can you add? As many as you want. This allows you to scale the service to any volume without any problems. Microservices sound impressive, but like any architectural model, they have their pitfalls. Let's compare a microservice app with a real company and understand the cons. The first thing that catches the eye is the complexity of monitoring. Each department of the company has its own tasks and requires an individual approach to job evaluation. In the world of microservices, this means that each service needs its own logs and metrics, as well as dashboard to track its status. The more microservices, the more logs and dashboards you need to maintain. Another point is the cost of teams. Technically, each microservice is developed and maintained by a separate team. It increases development and support costs. And, of course, integration between services. As in a real company, departments must interact correctly. To do this, we need not only unit tests, but also integration tests to make sure that all services work together without failures. Perhaps the most difficult issue with microservices development is data integrity. The regular situation is that each microservice has its own database. You can imagine that each department has its own file cabinet, but other departments often need information from related files, right? So how do we coordinate all of this? In theory, we need to come up with a mechanism that, if necessary, will request data from other microservices or departments, gives a command to change or delete, and, in the worst case, undo some previous changes. It seems that everything sounds logical and even application to real life. Often in a microservice architecture, we divide a large transaction into several small ones, each of which is executed in a separate microservice. This pattern is called Saga. Each microservice has its own database, and if other services need data, they need to be synchronized somehow. It sounds easy and simple, but there are a few features when working with the Saga pattern. Local transactions. Each transaction is executed within a separate microservice and updates its database. Event publishing. After a local transaction is successfully completed, the microservice published an event or message that initiates the next transaction in the chain. Transaction compensation. If one of the transactions fails, a compensation transaction is triggered and rolls back the change made by the previous transaction. An example of using the Saga pattern is an online store. If an error occurs at any stage, the system rolls back all changes to preserve the integrity of the data. Saga is a very flexible pattern that has several approaches: choreography and orchestration. Choreography is like a dance. Microservices like Pynest conduct a transaction passing it from one microservice to another, making the necessary changes in their databases. What does choreography give us? Pros: flexible and scalable. It's easy to add new microservices and expand the system. No single point of failure. There is no central component that acts as a bottleneck. Service autonomy. Each microservice operates independently, simplifying development and deployment. Negative points. Difficult to debug. Logic is distributed across services, making it difficult to track the execution of business processes. Opacity of business logic. The logic of task execution is distributed across microservices, which makes it difficult to understand and modify. Orchestration, in turn, is very similar to a distribution center, where there is a common single manager who indicates what to do with the received data. Pros: centralized management makes it easy to track and control the execution of business processes. Easy to debug. All interactions go through an orchestrator, making it easy to identify and fix errors. Clear business logic. The logic of task execution is concentrated in one place, which makes it easy to understand and modify. Cons: single point of failure. An orchestrator can become a bottleneck and a single point of failure. Scaling difficulty. Scaling an orchestrator is complex and may require additional resources. When to use? Orchestration. Suitable for systems where clear and centralized coordination of business processes is important, such as systems with complex business-critical processes. Choreography. Suitable for systems where flexibility and scalability are important. For example, microservice architectures in which services are very autonomous and change frequently. Microservice architecture is an excellent modern approach to the development of complex distributed systems that provide high fault tolerance. However, this approach also has its drawbacks. The choice between microservices and other architectures depends on the specific task and scale of the project. Personally, I always try to understand what kind of business will use the app, what its timeline and budget are. If you are planning to develop something scalable and large, microservices are a great choice. Also, if significant traffic is expected, microservices will be the best option. But if you're a small business and don't expect hundreds of thousands of requests per second, it might be worth considering a less complex approach, such as a monolithic architecture. The main thing is a rational approach to the task, and if you think that the monolith is enough, feel free to choose it. This is Eugene from Pynest. See you soon!